We could easily spend at least one whole term talking about heating and cooling, HVAC, they call it. And we don't have that kind of time, so what we're going to do is take a whirlwind tour quickly through this vast subject so that if you get a job where you're working in the HVAC field somehow, you'll have some basic vocabulary and some basic concepts on which to build. In this short lecture, we're going to look at just the basic concepts about heat. As a physics concept, you might say. When we talk about heating or we talk about cooling, we are talking about adding or removing energy. And heat energy is molecules vibrating. It's molecules moving around. And so if you want, you can think of thermal energy, that is temperature energy. You can think of thermal energy as kinetic energy, that is the energy of motion. And the word temperature, to be precise about it, is the thermal energy of the molecules in a material. And so what they are doing is they are jumping around, they're vibrating, and the more they move around, the higher the temperature. In the US, we measure temperature in degrees Fahrenheit. In almost the rest of the world, temperature is measured in degrees Celsius, and they're different scales. On this slide, slide 6, I'm showing you the formulas you can use to convert back and forth from Celsius to Fahrenheit or Fahrenheit to Celsius. And in the notes field of this slide are a couple of examples showing you how you would work through this. And then here at the bottom of the slide are just some key milestones. 32 degrees Fahrenheit is freezing. That's the same as 0 degrees Celsius. 212 degrees Fahrenheit is boiling. That's the same as 100 degrees Celsius. 100 degrees is boiling in the Celsius scale. And then in the world of drafting and design, we often calibrate our measurements to room temperature. And so I give you this equivalency here. This room temperature that we typically use is 20 degrees Celsius, which is the same as 68 degrees Fahrenheit. To be precise, heat is energy that's flowing as the result of a temperature difference. So temperature is that energy in those molecules as they're moving around. Heat is what you get when you have two things that are different temperatures, and heat is the energy that's flowing. In the US, we measure heat in BTUs, which stands for British Thermal Units. The rest of the world uses calories and joules. But we use BTUs when we're sizing our systems. And a BTU is the amount of energy it takes to raise 1 pound of water 1 degree Fahrenheit. That's 1 British thermal unit. If you want to get a sense of that, burning 1 wooden matchstick uses about 1 BTU. And when heat moves as the result of a temperature difference, it always goes from hot to cold, as these molecules are vibrating, and that kinetic energy moves from one to the other. So if a thing is hot and heat moves, that thing gets cooler as the heat energy moves away. If a thing is cold and some heat energy approaches it, it begins to warm up. And when there are two things that are different temperatures, they try to find what we call thermal equilibrium. They try to end up the same temperature. It's the difference in temperature that's making that happen. And here we are again with this idea of difference. In a plumbing system, water flows through a pipe because of a difference in pressure. In an electrical system, current flows through a wire because of a difference in voltage. And in a heating system, heat flows from hot to cold because of a difference in temperature. And by the way, there is a question that asks about this in our assignment sheet. It says, a difference in pressure makes fluid flow. What makes heat flow? And the answer is, it's a difference in temperature.